Hey, hello, and welcome to the show. It's me, JP. It's time for JP's Workshop. John Park's Workshop, that's the name of it. Hello, and thanks for joining. We have people over in our Discord chat, and you can get there if you want by going to adafruit.it/Discord. Jump on over to the live broadcast chat channel. We have Thin Man, Jim Hendrickson, hello, hello. Mike P, hi. Andy Calloway, hello. C. Grover, hey, thanks for stopping by. Let's see. The Thin Man asks, good afternoon, JP. Would like to know more about that orange box you hooked your keyboard to. Pretty cool on show and tell. Okay, I think I don't have it in here right now, but I'll bring that by next week. How about that? Yeah, that's the Nanobox Fireball. It's a little wavetable synthesizer. It's pretty neat, and they also have some others in that line. Little, very small synths that are super powerful. Just a couple knobs and a touch screen. So thanks for the question on that. I'll bring that by. How about next week? I'll do a little tool thingy, tool review, something like that on this show. Let me just pause the preview video. There's a little preview video that YouTube likes to put in the corner that's delayed by about 7 seconds and makes my head explode. So, what have we got going on today? I have a coupon code for you so that you can save some money in the Adafruit store. I'll tell you about some of the freebies happening right now in Adafruit shop. Look at some of the new stuff that's coming out, which is pretty exciting. I just placed a little order last night, so I got some cool, fun things headed this way. I've got a recap of my product pick of the week show that we'll do, a little 1-minute recap of that show. I have, as promised, I know I didn't do one last week, but I have, as promised, a CircuitPython Parsec for you today. I think it's a pretty neat one. What else? They're all neat, right? Maybe this one's particularly neat. And then I will do a little brief Learn Guide review on that Midi host project that Thin Man was referencing. And then we'll take a look at a new project, a Servo tester. It's going to be kind of cool. And you know what? That's a decent segue for this week's product coupon, which is servos. So if you want to get 10% off in the Adafruit store, just head on over to adafruit.com. The main page is the store page. And if you throw some stuff in your cart and want to get 10% off, then don't miss that little coupon code box on the way out, and in it you'll want to type that right there, servos. Speaking of the store, if you head on over to Adafruit, there's a little new product section right there. You can see this is neat, this little snap-on enclosure for the TRRS Trinky. I ordered one of those to check it out. So this is unlike some of our other cases we've done in the past, this is not an injection molded case with expensive tooling that has to be made for it, but instead a 3D printed case made by, I think, JLC PCB or someone like that. We sent it off. So Ruiz Brothers designed this, but this little case was printed sort of in a batch setting, and I think maybe it's in nylon or some other semi-exotic material. So I'm excited to check that out. I think it's glow through as well. It's a little bit translucent, so you should get a little bit of NeoPixel shine through it, which will be nice. Oh no, they said it. Yeah, it's an SLA process. So it's a powder, probably nylon, that gets sintered by a laser, and eventually all of the non-sintered stuff gets brushed off and reused, and you're left with just the grown product in the middle. So that's one there. You can get 10% off of that. But if you head on over to products, we've got a whole section of new products right here. Any of those that you want that are in stock, you can get 10% off today with that coupon code Servos, and that's good until midnight East Coast US time tonight. Oh, someone said, Andy Calloway said, I'm worried that Lars is not in the shop. Oh, Lars is in the shop. Yes, he is. He's still hanging out there with his wearable dress vest thing. But he'll disturb you more later. In the meantime, let's take a look at my product pick this week. So this was a new one and kind of a novel one with one very specific use and then a lot of generalized uses. And on that show, I go over a new product and give you 50% off usually during the show. This week it was this guy right here, and here's a little 1-minute recap. 555 PWM output stemma. So I've got a PC sitting on my workbench, and right here I've got my little 555 timer, and it is plugged into the power and ground and tachometer reader pins on the motherboard for the system fan. I have disconnected the case fan. Normally, if you disconnect the fan on this type of motherboard, you're going to get an alarm. But in this case, that fan is totally unplugged. It says the current system fan speed is 1,155 RPM. I'm going to turn the little screw there. You'll see I'm essentially fooling the BIOS into thinking we have the fan running down in the 700 RPM range, or I can start to turn that back up. 555 PWM output stemma. Yes, indeed it is. So go grab some of those. They're pretty neat. So next up, I've got this. CircuitPython All right. Ooh, blue glowy lights. For the CircuitPython Parsec today, I wanted to show you how you can use the pressed and released states inside of the keypad library. So there is a built-in library in CircuitPython called keypad, and it's useful for all kinds of button uses, in this case a fairly literal keypad. And you can see here in my code, I've imported keypad, and then I'm doing some display stuff here and some NeoPixel stuff. And then I set up my keypad to be a keypad, what's that? Keypad object, that's right. I set up the keypad object named keys, and it uses these 12 board pins to be the keys that are inside of that object. And then we also set up the state as far as a value when it's pressed and if it has a pull resistor. So in the main event here, so in the main loop here, in while true, we have an object called event, which is based on keys, events, gets. So this goes and gets all of the keys that have some sort of state change going on with them. If there is any event of any kind, this could be that something has been pressed, that something is being held, that something has been released, then we're going to run some checks. Now the simplest version of this, and you'll see this in the most basic examples, is I'm going to set the text on the screen and change a pixel color and show that pixel color. So this is when I press something. So I've pressed the first key, we get a 0 on the screen, and we change that LED to red. Now you can see, as I'm pressing each of these, it sets that state. But it doesn't really know about me releasing it. It's just kind of waiting around for that to be pressed. So this slightly more sophisticated version you can do, if you look at my code here, I'm going to uncomment this bottom section. Here you can see I'm actually drilling down a little further, and I'm saying if the event is that it was pressed, then we're going to list the key number and we're going to set the color to red. But if that key gets released, we're going to change the text to a couple of underscores, and we're going to set the color to blue. So if I resave that code there, you can see now when I press, we get one thing. When I release, we get another. And so this is just a little bit more sophisticated, a little bit more useful in a lot of cases to know not just that something got pressed, but that it also got released. And so that is how you can use keypad with the pressed and released states inside of CircuitPython. And that's your CircuitPython Parsec.
CircuitPython
And I also glossed over some of the other stuff in here that you may be interested in. The main things being in our display setup. I've got a label object. That's what's being used to create these numbers. And I'm using the built-in Terminal IO font. You can get fancier fonts. But the little OLED screen here can either be black or white and black. You can set a white rectangle and use black text if you want. But it's pretty straightforward to use, and the only thing I need to change when I want to adjust that is the object, which I named text.text, and then whatever string you want to feed it. So when you press any key in keypad, it actually registers the key number that's been pressed from that list. So it knows that that's key number 4 that's indexed from 0, and so it sets the event.keyNumber both as the number of the neopixel that we're pressing and as the text that we're actually going to display up there. So these are really useful. I tend to find myself using keypad more and more, even when it's just simple button presses, because it has a nice, easy workflow, very minimal setup. Debouncing is built in, so there's a lot of benefits to just using keypad when you're doing any kind of button pressing types of things. All right, so let's next move on to, I had a little bit of a, let me switch cameras here, sort of a retro gear review. I got for free from a friend who was holding a yard sale a few weeks ago. I helped out with the yard sale, and he gave me this. So this is a little Atari paddle you can see here. It's plugged into a little battery box, and it has a composite video and an RCA cable for mono sound. This is essentially a little epoxied chip there that has baked in a little set of Atari games that you use the paddle for. All of it's there. This is, I think, just providing power, and then the output of audio and video head back that way. So I think that's what that cable's doing. This is, I think, just the battery box. I don't think there's any electronics in there. So when you power this on, this little on-off switch here, it will give you a VGA, or rather, it'll give you a composite video signal. So I'm plugging it into this little monitor. This happens to be a black and white monitor, but this is color output. It's just what I had convenient right here. So I'll turn that on. You can see it's called Basic Fun Inc. It came out in 2006. And if we press the buttons on there, we get to pick between Pong, Breakout, and Warlord. It is very hard on a black and white monitor to tell which one is picked. I think that is Breakout. It kind of shaded a little more there. So I'll start that. Oh wait, did I reset it? I think I reset it. There we go. Oh, I picked Warlords. Okay, well, we'll play that. Maybe. Okay, yeah, so it's, I don't know if you know this one. This is kind of like a version of Brickout that takes place in a couple of axes. So kind of neat, but the thing I was really excited about with this is that it is an incredibly small composite video tester. So sometimes when I'm hunting around for old CRTs, I need something to plug into it. And I've used my little CircuitPython ESP32 composite video nub before, but it's a little bit exposed. I've never made a nice case for it. So this is another nice option here. I think the batteries are dying or something. It's flaking out, or maybe there's a flaky button. But really neat that we have a fairly contained thing that will give us, just bring this up to something, plug it in, and you'll get a little video signal. This had a little keychain on it too. I removed that, but the idea behind these is that they were little alleged keychain games. I don't think you'd want all that hanging off of your keychain. Maybe you keep the battery pack in your pocket. But kind of cool and kind of useful, and not so trivial to have a nice clean composite video signal out, especially a color one like that. Maybe I'll demo it again on a color monitor for you sometime when I have a chance to set one up. But pretty cool, and it could have been useful when last time I went and picked up a TV from someone. I brought this, which is a little Retro Duo, which plays SNES and NES games on a real chip. I think it's a clone of the real chip, not an emulator. And but that's less convenient. It's a lot bigger, so I'm kind of digging that little paddle game thing there. You could probably pick one up for $10 on eBay or hunt around thrift stores and yard sales and things like that if you're interested. All right, so now let's get on with a new project. And so let me show you the inspiration for this first. Let me do servo tester. Let me look for the actual link of the one that Lamore sent me. Oh, here it is. Servo controller is what this one goes by. So this right here is a pretty neat tool if you're doing stuff in robotics or other things that require using servos, and you need to set positions of servos, maybe to put into other code, or you want to directly control them, and you want to figure out what's the ideal minimum and maximum pulse lengths for getting to the far left and the far right that's available. So usually you'll figure this out in code. If you're an Arduino or in your CircuitPython, you'll adjust stuff and see how it goes, resave it, adjust stuff. So the idea behind these is to just be able to directly control with an encoder or a potentiometer knob the position and then maybe a few of the settings on there. So this is a really nice one that comes in a little, looks like 3D printed box, has a PCB top and bottom on it, nice big screen on it. I believe there's a set of 4 batteries underneath. So really cool, and we just wanted to, Lamore's suggestion was make a minimal version of this, not quite as fancy or nice, but a minimal version of this on a Proto board that allows you to do some similar things. So maybe plug in a couple servos, have a couple knobs and other buttons. And so what I've come up with in prep for this last night is this little gizmo that you see here. So what I've got on the bench there is a ESP32. It's going to be a reverse TFT S2 version. I happen to have a S3, which is what I'm using, but I think we'll just use the S2. It's on a breadboard. I have a I have a encoder that's plugged directly in. So I'm not using a breakout. I'm not using I2C. We want to keep this cheap and simple. I'll probably just solder that directly onto the board. And all you need is a couple of pins to be able to read the pulses of your encoder, and then another pin to read the button that's built onto the encoder. And then outputting PWM, a single pin, and then power and ground. And I'm using a little battery pack. So you can see, let me move this out of the way. You can see there's a 4AA battery pack that's powering just the servo. I may put a capacitor on there too, just to calm the noise down and see if maybe I can run both the feather and the motor off the same supply. It's not usually a great idea, but we might be able to get away with it in this case. So let me head on over there and I'll show you this in action, and then we can take a look at what the code does so far and where I'm headed with it. So I'm gonna zoom in a good bit here. And I'm sorry, let me turn, yeah, I'm afraid if I turn off that AC there that's blowing, it's what's moving this camera, that other camera is going to overheat. It kind of happens. So if you take a look here, I've got the TFT displaying the current angle. And then you can see as this is not over I2C, this is just a simple little breakout I had made at one point for encoders. So as I increase that angle, I've got my little servo motor heading over to its far left. These happen to kind of confusingly be opposite. I may just leave it that way because it seems normal to me to turn to the right to increase the angle number, and that's 180 happens to be over there on the left. So I'm able to dial that in really precisely. One tick of the encoder is 1 degree, and you can see the encoder angle listed here on my pop-up. The smaller text, which you can't see, is telling us the current pulse range. So we have 600 to 2410. And right now I just used iteration in the code to come up with the best values that gave me the maximum possible. I've got, I think, looks like just about 180 degrees there, which is nice. In the future, what I'll do is allow a mode where it sweeps from its minimum and maximum as you adjust those numbers, which would be a kind of nice efficiency rather than just typing things in and seeing what you get. And then I added a couple of other features. So if I click the click encoder, it'll just jump to 90. However, the angle value that the encoder is going to set, you can see it's going to jump here. It still remembers where it was. So I can head somewhere and then go to 90 and head back. So this is helpful in testing its sort of fastest speeds that it's going to get places. And then the other thing I wanted to do was start to come up with a little bit of a user interface for saving positions. So right now there's these 3 buttons on the side of the TFT. If I press the first button, or sorry, D1 button, it's going to store that angle. So now it's going to just remember angle of 41. So if I go somewhere else now, I can recall that by pressing D2 button. If I press my encoder switch, it goes to an angle of 90. If I press D2, it goes to my stored angle. So if I head maybe over here and store a new angle, 172, same thing. I can go to 90 with the encoder, and I can go to my stored angle of 172 with the D2 button. And then this can be, probably I'll just set this for 2 encoders. So I'll have 2 encoders and 2 servo motors on here. And that'll be about it. So it'll be quite minimal. If you're looking for something more fully featured, check out that one I showed there on Tindy. But this one will be something that you can update and very simple to code and iterate because it'll be in CircuitPython. So let's go ahead and I'm going to unplug this. Feather was just being powered over USB-C, and let's just go ahead and grab the whole thing and we'll plug it in over here and just take a look at what the code is doing right now. Mike P, I don't know the answer to that. Mike P asks, what causes it to hiccup every once in a while? Just rapid change in value? I'm not sure. It could be that it could be a lot of things, actually. It could be the noise. We could be getting noise from the motors that's screwing around with the logic. That's possible. And a smoothing capacitor might help with that. Could be that the value range I've given it of its minimum and maximum aren't quite right. So I might be sending it too long of a pulse or too short of a pulse. Which is causing it to wig out a little bit. I think I was seeing that at one point more when I was letting it go all the way to 180 physically. So when I brought that number in a little bit, it didn't do it as much, so I may just not really be able to get a full 180 with this one mechanically. If people have other ideas of what could cause that, though, I'd love to try other stuff and hear other ideas on that. So now I'm going to go ahead again, plug this in over USB. So you can see when it starts up, it goes to an angle of 0, and the encoder is set to an angle of 0. And now as I turn that up, you can see it increasing there. Let me go and adjust this exposure so you can see a little better. That's kind of wiping the screen out. You know what I'm going to do? So let's go into the code here. And I'm going to adjust the background color to be black. How about? So let's find. Yeah, I think that'll be easier to read on the. I think this camera doesn't love blue. In fact, it kind of tends to white out the blue. So there you go. So that's the basic operation there. Yeah, if I really whip it around, I think it's still okay, but it's sometimes near these edges. Oh, I'm going the wrong way. Oh, what have I done? Hey, let's look in the print. Let's see what numbers it's. I don't have it clamping the value of this, so it's probably down in like the 300 range or something like that. Let's go to terminus and Disco Tool ESP. Oh yeah, so right now it's my encoder. I spun it all the way around to a number that's nowhere near. It would be faster to reset, but I just want to show you this. So eventually it's going to get to 180, and then this will start moving. So I've clamped the values that can be sent to this, but I don't have any code to stop the encoder from accumulating numbers with its little pulses. Over in the chat, some nice said I was going to ask about servo easing, and found a CircuitPython Parsec I had done on that. I should probably review that. I forgot about that. So yeah, you can see here it's going to get into negative values, and let's do like 3 turns. So now I have to kind of unwind that to 0. Unfortunately, I don't think there's an easy way in our rotary I/O, which is what I'm using for the encoder, to sort of reset it. I feel like I've done that before, but maybe it was with our stemma I2C code for the seesaw, rather, the seesaw boards. But I'll have to look into that because it would be nice to basically clamp this so it stops accumulating values beyond the range that can be used on the encoder as well as the servo. So okay, let's take a look at some of the code that's going on here. So I've got some imports here, some display things. I'm using rotary I/O for reading the pulses of the rotary encoder, and then I've got PWM I/O to be able to talk to the servo, as well as Adafruit motor has some servo convenience library stuff. And mentioned earlier using keypad, I'm using it for the buttons. So right now that's just the encoder button there, and then these two, I'm just using D1 and D2 right now for storing and retrieving angles. So the first thing we do is I've got some variables here. These are the ones I was adjusting to see how far I could physically get the servo to go. 0 to 180 is an ideal, and not every servo does it, so sometimes you'll come in a few degrees on either side. And this is what allows you to sort of clamp that. In fact, if I go to 0 here, you can see this is basically to the far right. Unfortunately, the way I put my little arrow indicator there, you can see it's a little off from the heading of this thing. So that's 90. Here's 0. If I think it's this side of it. If I make this number smaller, let's make it obvious, 1500, then I believe what it will count as, okay, so you can see the range has been constrained, so that's now where it thinks 90 is. So it's still making it all the way over here. That's what it thinks 90 is, and let's see, and that's what it thinks 180 is. So the sort of constraints of the pulse minimum and maximum are what set the sort of physical range that it tries to turn to. So I'll reset that number there, but like I said, these might be neat to have available right on the display to try out while it's in sort of a sweeping mode and just tighten up or lengthen those out. Yeah, C. Grover said in the chat, by the way, I'll pull up the chat for a second here. If I recall, set the encoder to value encoder.position equals 0 or whatever value. Yeah, that's right. Okay. For some reason, I talked myself out of that last night, but maybe I didn't ever try it. I think I confused myself. So yeah, that would be great. So if I hit 0, I'll just, if the number gets smaller, I'll just reset it to 0. And if I hit 180, I'll subtract it back to 180 so that essentially we don't end up with this accumulation at the ends. So these are these two variables here. The reason I did them as variables is I want to, like I said, in the future be able to maybe adjust them with the knob. And I'm also printing them up here so I don't have to hard code that. Let me zoom in real quick so you can see that a little better. So pulse range, if I change this, let's go back to this 1800, say. Now I can see, okay, here's, hey, that's funny. It's acting not got enough range for my liking, and I can look there and see what that maximum pulse was set to. So I'll change that, save it, and now it'll show up here. One that may be useful is the frequency. I've got this set at 50 hertz. I think that is exactly what these servos want, and maybe you'll run into some servos where you'd want to change that. So that could be maybe an advanced setting to adjust what the pulse frequency or the PWM out frequency is. And duty cycle, those are all things that you could potentially be adjusting as well. Okay, let me refocus that. Next up, I've got the encoder, so I'm using rotary I/O, incremental encoder, and then telling it 2 pins on the board, and these could be any digital pins. So I happen to be using the top row there for this stuff. I think I have A0 through A5, and I was just planning to use those for the 2 encoders, which have 2 pins for pulse and 1 pin for the button when you press the encoder in. So I'm creating a variable called enc position and last enc position that's initially set to none, and that's what we'll use to check to see if we've moved, if we've changed at all when those two aren't the same. So this just stores the state. And offset I'm actually not using. That was going to be my part of my plan for removing excess turns in either direction, but I think I won't need that if encoder.position equals 0 or 180 works like C. Grover suggested. So thanks for that. Now I am actually using keypad in 2 different instances here. So I have the encoder buttons, and right now there's just A0, but I'll be adding A4 when I plug the second encoder in. And then the TFT buttons, and right now I'm just using D1 and D2. The reason I don't have D0 on there is I actually think I need a additional keypad object for that one, because that one is pulled high and the other 2 are pulled low, and I don't think there's a way when you make a keypad object to pick and choose which buttons are set up which way. I think the whole object is set up one way, so I believe I'll have a separate button for that D0, but for now I just punted and used those 2. But it would probably look something like this with value when pressed true, pull false. I think that's what that one's going to be. And then we have some display set up. I've got my little black bar at the top with that additional info. Only makes sense that I have a black bar there when I have this background turned on. So I'll turn that back on just to a darker color maybe. There we go. Then we've got some labels, the pulse range label up at the top, and the angle label in the middle. It's not going to display that degree symbol. So initially that's just hard-coded as 0 because I set the thing to 0 at the beginning. We could tell it to start at 90 and I could set that to 90, which is usually the middle. And then we show all of those display groups. I have a function here for setting the servo to 90 degrees. I'm going to generalize this to set it to n degrees and have an argument so that we can use that more efficiently for things like the recalled positions and stuff like that. So that's not really necessary right now, but in the future I think it'll do a little more. And then the main loop, we've got the encoder button event, so that checks for this button or any encoder buttons that I have in there. And if there is one that's been pressed, then I'm just calling that set servo to 90 degrees. And then we have a TFT button event, so that checks these two over here. And if the key 0, which is the first one there, is pressed of those two, then I'm storing my angle. So show that again. I'll set my angle, let's say to 45, store it, boop, and right now it prints out stored 45. Now I'll go to 90 just by clicking the encoder, and then when I press D2, it's going to recall 45, and that'll update. I'm not printing that on the screen right now, but I will. So now we've stored 143, and we can recall 143. Then after we've done all those button checks, we check the encoder. I've got a variable called enc_position, which equals encoder.position. I check that to see if it has changed since the last time I touched it. And if it has, I'm printing out that encoder position. And I'm also setting the angle of the servo to be this variable called angle, which is a min-max of the encoder position and then 0 and 180. So that's what stops it from trying to go beyond, which will cause the thing to crash. So we don't want that, both physically and softwarily. Then we set the servo motor angle to be equal to that clamped min-maxed angle. And then I update the text on the display itself with textarea.text. And then last thing is I change the state of the encoder position back to a equal the current encoder position. And I'm not sure if I need this sleep or for it to be this aggressive. Let me see. I don't know if that'll speed things up. Yeah, it speeds things up quite a bit. I don't remember why I had that one in there. So yeah, so you can see there are sometimes these little, there it just jerked and missed it a little bit. I'm not sure why. But I could also potentially go to async IO so that I'm not interrupting some of these servo commands because they're one at a time, right? I'm not saying go to a position and letting it get there. I'm just sending one angle change at a time. So I may put that into async IO so that scanning for buttons and scanning for the encoder doesn't interrupt that flow there. That's probably a decent idea to separate that out. This also means we could potentially operate both servo knobs at the same time without them kind of getting in each other's way. So could be a good case for async IO. All right, and that is it. So that's what's going on in the code, and that is the new project. Planning to probably just put it on a perma-proto board, and you can put a couple rubber nubs under it or standoff, but leave it basic, simple, and then if you want to put it in a cigar box or 3D print your own cover for it, you can. One other last thing I'll show. This is a favorite tip and trick, especially on breadboards and permaproto boards. I'm using our extra long headers. Let me go to a full screen of these. They're worth it. So these are extra long header pins, and we sell them in little packs of like, I don't know, 10 by 10 or something like that. These are great for plugging in your servo cable, which is always going to be this socket, into either your breadboard or your permaproto for soldering. If you want that, you may not need that extra length in that case. If you're soldering it from the bottom, the amount that a normal header sticks out should be fine. I think this other side is that same length. I think that's a standard. If only I had a million header pins. Here's some. So actually they're a little bit longer, and maybe you need that length, maybe you don't. I think this actually is proud of it by a little bit. Yeah, so it's a little excessive. But these are really great for the breadboard, and then you can see here I'm just plugging that into power ground and signal there. You just got to make sure you pick the right one. But those are useful. I've also got a little, while I'm testing stuff, it's nice to have some available pins coming out of the ground rail there. So I use those if I just need to short something to test it, if I'm feeling suspicious about a button or something like that. And I actually used some of those to make this breadboard friendly battery pack adapter. So this battery pack, I don't think we sell any with header pins on them. Maybe we do, but this one had just wires. So I used couple smaller pieces of heat shrink under here, the long headers, a long strip of the insulation taken off, wrap them around, solder it, cover it in heat shrink, and then another heat shrink around the two of them. Just pay attention to positive, negative, and then I can plug that into the breadboard rail there and get my power to the rail. This one just popped out over here. That's the button. Let's see, do you still work after all that? There it goes, yeah. Okay. So that's the project, and stick around. I'll probably be able to put this together pretty quickly and get a Learn Guide up for that. And speaking of Learn Guides, that takes us to our last couple things here. I'm going to head back to Adafruit, Learn, and we've got our new guides section. Here is this USB MIDI host messenger that you've seen me working on for a couple weeks. I just put the Learn Guide out. This is it. I've got a little overview page here along with a video you can watch of some of its functions in action. There's a little close-up of it there. I made a little 3D printed base to put it in, but I decided not to cover it because there's a lot of buttons you want to get to on the top of it. There wasn't much I ended up covering. I just decided to leave it exposed. But you could choose to put a top on it if you want. So we've got Arduino setup instructions here for using this, which is an RP2040 feather. So you need to do the Philhauer core setup in Arduino to get that working. Or you can, since it's just one specific board, I made a UF2 file. I think it might be an add-on to your Arduino IDE. I'm using the 1.8 IDE, and there's an add-on that lets you compile a UF2 rather than compile and send it to the board. It compiles and wraps it up as a UF2 that you can share. So this right here, USB MIDI host, is if you put your feather into bootloader mode, put CircuitPython on it, then you can double click and it'll accept UF2s. Then you can override that. Actually, you don't even need CircuitPython on there, but as long as you've got the right bootloader on, you can drag this UF2 onto there, and you don't have to go through any of the Arduino setup and compile. The options, though, if you go and set it up so you can code it yourself in Arduino, are many. So you could do all sorts of neat additional tricks with this project. I do have a code walkthrough here that takes you through the basics of how it works, what it's doing, some of the Midi message handling, what the different cores are doing. So that might help you if you decide you want to add some other things like your own arpeggiators or chord modes or transposing, what have you. This is a little section, little page here on putting it together. So you'll solder up a quad feather wing, and you'll also add a enable switch there. So that's a little switch that I use to essentially turn it on and off. Use some nylon standoffs, both to secure the things to the top, especially Midi cable and USB cable you might be tugging on, so I didn't want to strain the poor little header pins there. So you'll screw those in, add the battery, and these are the screws that hold it all down. There it is, ready to go into the optional case. I also included a template here. This is a PDF file. If you print that at 1:1, you can use that as a drilling template and cutting template if you just want to put it inside of a cigar box or something like that, or onto a piece of wood. Screw it in from underneath. Don't make fun of my bad first layer print there. And then usage section. Takes you through using it. There's that little nano box that Thin Man was asking about earlier. And yeah, that thing can't host MIDI. Most synthesizers can't be a MIDI host. It's really the domain of computers. So that's why I'm so excited about this little gizmo sitting in the middle. And then going through using it to change your MIDI channels so that it can come in on whatever channel and go out on whatever channel. Using the program change to shift among the 127 possible sets of presets. And I also just am spying on the CC number. I'm not doing any remapping of that, but you could. I just ran out of time to code up extra UI necessary for that, really. But you can turn a knob and see what CC is this even coming out on, which can be useful in some scenarios where you have to then tell your synth or sequencer what to accept. And then I've got the third button on that little OLED feather wing acting as a MIDI panic. So if you got a hung note, this will just turn off all notes. And when you play notes, they will show up by number, as well as I'm just turning on a little like whole note symbol there. It's actually a lowercase o. And that will just let you know when you're pressing or releasing a note, note on, note off. You can also have this sending out everything that it's sending out over the MIDI UART. You can also be sending out over USB back to a computer or something that can host. So this does allow you to essentially act as a little filter box between a USB MIDI keyboard and a computer if you want. And there's some ideas on customization. And that is it. So that's the guide there. Before I go, two last things. I had some questions in the chat I just wanted to check. Let's see. One was Donald Geisler over in YouTube. Hello, Donald. Says, do you have a component parts list and schematic of this circuit with code on a site link? That will be coming. So that'll be the Learn Guide I do. If you're talking about the encoder project, that's going to be probably next week. I'll have that out. And yeah, interested in this encoder, never got to play with one on a motor. It's a lot of fun, especially because we have this kind of one-to-one relationship, which you could adjust, right? You could have maybe press and hold multiplies it by 10, and you can whip it around real fast. So it really depends on your needs. But I think this will be something I end up keeping around as just a little piece of sort of test equipment for servos. Because, you know, we've got, for example, these little... Where'd you go? Oh, this is kind of neat. So here I've got a little sort of XY axis 2 servo gimbal thing. So if I plug one of those in, there's a chance that it will want different pulse settings. And let me show the downshooter here again. And so being able to control that stuff and just figure that stuff out from this piece of hardware would be pretty nice. So I'll plug this in. let me zoom the camera out a little bit more. Okay, so let's see. I've set that down to 0. Let's go up to 180. Oh, this one seems to like those numbers, actually. Funny. It's a bad example, but yeah, this is a very different little little servo. Let's preset. And the nice thing with this is sort of a little side-to-side, up and down, sort of yaw and roll type of thing, or tilt and roll. Tilt and yaw? Pitch? I don't know. Some of those things. Can be kind of neat to use these stored positions to test sort of aiming at things. So I can get quickly there, go quickly there. So neat for sort of animation types of things. If you're doing animatronics, you might be into this kind of thing. Yeah, so that'll be the idea with that. Is that it? Yeah, I think that's going to do it. So final thing, I'll just remind you, if you want to go and get some servos, maybe get a feather, get an encoder, breadboards, whatever you want. If you want to get 10% off all that cool stuff to build some things like this, or go check out that Midi USB host messenger project and throw some stuff in your cart. I think the host feather might be out of stock right now. I can't remember. But throw some of that stuff in your cart, and you're going to get 10% off on your way out if you just type servos into the coupon code box on the way out. So that's your coupon code for today. Thank you. Some nice pan tilt. That's what I was looking for. Pan tilt. All right. I better go. We should all go, right? Okay. Thanks everyone for stopping by. I believe there's going to be a deep dive with Scott tomorrow, but check on the Discord or the blog, and then we'll be back next week with a whole bunch of other shows. We'll have a product pick of the week on Tuesday. We'll have a 3D Hangouts Wednesday, show and tell, ask an engineer. There's probably a random desk of Lady Ada at a random desk of Lady Ada times. Who knows? Top secret things are often revealed there. So stay tuned. Watch the blog. Watch your feeds. And be good. All right. Thanks, everybody. I will see you next time for Adafruit Industries. I'm John Park. This has been John Park's Workshop. Bye-bye. Say bye, Lars. Bye.